Okay, in the first part I measured the damping factor at different locations, like it should be done at the amp, and for interest at the load. This, to me, is a more realistic point of view, as now the speaker wire is included into the damping factor, rather than included in the load resistance. We have seen that the speaker wire significantly reduces the damping factor due to its additional resistance. Now let's compare the behavior of the damping factor for different lengths of wire and coiled versus uncoiled wire. We saw that we can calculate the damping factor out of just the voltage measured across the speaker leads with and without the load. Using the same test setup as before, but with the possibility to use another cable for more lengths, I continue the experiment. I'll be measuring only at the load with different cables. Let's see what comes out. For an 8 ohm load and 10 meters of speaker wire, we see that we end up with a damping factor of about 33. Now adding 10 meters of wire to the connection length further decreases the damping factor to 19. This is coiled wire. Now the same length uncoiled. As we see, in my case, this makes no difference at all. This is not very surprising, as I did not see any difference between uncoiled and coiled wire when looking at general wire losses. Nevertheless, it is interesting to see how much of a difference the wire length makes towards dampening factor, as does the speaker impedance. Here we see a measurement of the damping factor of a 4 ohm load, which is connected with 10 meters of wire. As we again see, it's about half of the value of an 8 ohm load. With double the wire, it again is about halved, whether uncoiled or coiled.